Hello guys! In this video, I'm going to tackle about centroids. Includes masses, lines, areas, and volumes, both in 2D and 3D system. First, we have to know the three main objectives. These are the following: the location of the center of gravity, the location of the center of mass, the location of the centroid, using the method of composite bodies. Before we go on solving a problem, you have to know what is centroids. Used when the calculation concerns a geometrical shape only of a homogeneous material. We will find the centroid of a circle, rectangular prism, or etc. Now, center of mass. I will give you some example of center of mass. We can see the broom is balanced by a fulcrum. The fulcrum is there because the center of mass is here. If the fulcrum is right here, the balance will be off and it will fall counterclockwise. So I guess you have an idea of center of mass. Centers of gravity. It is just the same manner of center of mass, only that it is concerned with a gravitational effect like the Earth. Axis of reference. The axis of reference is the location of a body, centroid, which is usually assumed or a given axis. Later you will understand the axis of reference well while we are solving. So next is the method of computation. There are two types: integration method, used in irregular or bodies shape; moment method, used for geometric composite shape. These are the formulas of integration method. You need to remember these formulas. And this is the formula for moment method. Next, here, you can see centroid of simple line segment. All straight lines have centroid located at the midpoint of each segment. So in every straight line, there is a midpoint, and that is called centroid. These are some important formulas that you really need to remember: quarter circular arc, semicircular arc, and arc of a circle. This is for lines. You will only include these lines and this line. And the length of quarter circular arc is pi r over 2. The length of semicircular arc is pi r. And this is the x and y components of the given shape. We have another important formulas to remember. Triangle, of course, that is 1/2 BH in the x and y component. And semicircle, guys, I forgot, this is already area. Before, this is lines, okay? Remember, this is lines for lines, and this is for areas. This includes this whole area, and for semicircle, this whole area. Okay? So for semicircle, pi r squared over 2, the area of quarter circle, pi r squared over 4. And for rectangle, of course, base times height. Guys, you need to remember that formula, okay? And these are some other formulas to remember. Volumes for cylinder, for cone, pyramid, and etc. This is a sphere and this is a hemisphere. And don't forget guys that in volume you need to put cubes, and in area you need to put squares after the units. So next, centroid of other important figures. So we have trapezium, right cylindrical cone, hemisphere, and segment of hemisphere. Next, these are the steps. Step 1. Locate the axis or point of reference with consideration to the positive and negative axis. Step 2. Divide the figure into finite simpler segments or shapes with known centroids location. So there is a note. It says treat the holes or empty spaces into composite components as negative weight or area. So we move on to the step 3. Measure centroid distance of each segment with respect to the point or axis of reference. And step 4. Apply moment method by using the previous page. So there is a note again here. It says if an object is symmetrical about an axis, the centroid of the object lies on the axis. So later, we will apply all of this while solving. Okay, so we're having our first problem. Our first problem is this. Lines in 2 dimension. Locate the centroid of the given closed line figure of a right triangle with respect to the given x and y axis. So we have the two givens, 13 meters and 14 meters. First, we need to find the hypotenuse. So how can we find the hypotenuse? By using Pythagorean theorem. So 13 squared plus 14 squared is equals to 365. So we will put here 365. So first thing we do, I will name the lines. I will name this line 1. I will name this line 2 and this line 3. So second, we have to find the centroids of each of the line. So the line 1, what is the centroid? X and y component. So the x component is 0 and the y component is 13 divided by 2, and that is 6.5. 6.5 there. That is a 6.5. So next, the centroid of line 2, the x and y component. So the x component is 7 because 14 divided by 2 is 7. Y component is 0 because doesn't go in the positive y axis or negative y axis. So the centroid of line 3, guys, this will be tricky because you will just copy the x value of the line 2 and the y value of the line 1, 6.5. There you go. So we have the centroids of each of the line. So the next step is I'm going to show you two ways on how to solve this problem. This is the first. So line, I will put the lines line 1, line 2, and line 3. So the length of line 1 is 13, length of line 2 is 14, length of line 3 is, oh by the way, this is square root of 365. 365. So the xn, it means the x component. We're just going to copy this x components. It's 0, 7, and 7. in the y components of these lines. So we have 6.5, 0, 6.5. So here it says, oh wait, I will just total this because the total is very important later. 13 plus 14 plus square root of 365. Let's assume this is 46.10. So the total length is 46.10 in meters. Okay, so it says here ln times xn, so we will going to multiply this to this. 13 times 0 is 0, 14 times 7, if we put that on our calculator, the answer will be 98. And square root of 365 times 7, if we put that on our calculator, the answer will be 133.73. So next, our ln and y component. 13 times 6.5, the answer will be 84.5. The next is times to 0, the answer will be 0, and square root of 365 times 6.5. The answer will be 124.18. So guys, it's very easy if you will bring your calculator with me, so you can follow. So after that, the summation of ln and xn is equals to, we will just sum up this ln and xn. 98 plus 133.73. 133.73. The answer is 231.73. 231.73. There. In meters squared, because you times it. Next is 84.5 plus 124.18, 208.68. The summation of ln yn is 208.68 meters squared. So after that, we will be having this kind of formula. X component, summation of ln xn over total length. There, that is our formula. So ln, summation of ln xn is this one, 231.73 over the total length, 46.10. So if we put that on our calculator, 46.10, the answer will be this, 5.03. 0.03 meters. Don't forget about the units, guys. Meters. So in y, same, ln xn and total length. Oh, this is yn, equals ln yn, this is that, we'll put 208.68 all over the total length again, 46.10. So we'll put that on our calculator. 208.68 over 46.10. This will be the answer, 4.53. In meters, don't forget. Oh my god, sorry. In meters, guys. There you go. So this is the answer. This is the centroid of this figure. So I'll show you the shortest way. This is the long way. So I'll show you the short way. So you will put the length of line 1. Length of line. You will put the length of line 1. The length is 13, and of course multiplied by its x component. This will be 0. As you can see, this will be cancelled because 13 times 0 is 0, plus the length of line 2, 14 times 7, because this is 14, that is the length, and this is 7, that is the x component. Same as here, times 7 all over. You will just copy the lengths because you will put over total of the lengths. Square root of 365. So if we put that on our calculator, the answer will be the same, and I will show you. So I won't put 13, so I'll go with 14. 14 times 7 plus square root of 365 times 7 all over 13 plus 14 plus square root of 365. The answer is 5.02. Are we correct? The answer is here. Okay, it's the same. It is just rounded off. 5.03. 5.03 in meters. The same as in y component. Just have to copy the length multiplied by the y component, that is 6.5. 14, the y component 0. We can see that this is 0, it will be cancelled. 365 times 6.5, 13 plus 14 plus, we'll just have to copy this again to here. So I'll show you again if it is the same. 13 times 6.5 plus, I'll not write the 14, move on to the square root of 365 times 6.5, 13 plus 14 plus square root of 365. So the answer will be 4.53. In meters. Let's see if we're the same. 5.03, 4. Okay guys, this is the shortest way, so this is highly recommended. Okay, we're done to our first problem. I'll just have a short explanation to this problem. So this will be our centroids, the x and y. If you plug it here, the centroids is right here, because if you put 5.03, it is somewhere here. This is 5 and this is 4. It's about 5 also, but it's 4.53. So this is the centroid of this figure. Thank you. So let's move to our next problem. Lines in two-dimensional. Again, locate the centroid of the given line figure with respect to the given x and y axis. So our first step again is to name the lines. So I will name this my line 1, my line 2, and line 3. So we don't have the length of the line 2. So we have to get the line 2. So how can we get it? By using the formula. The formula is pi r. That's the formula here. Semicircular arc, pi r. So the radius is 3 inches. So if we substitute the radius here, the answer will be correct, 3 pi. So again, after naming, let's find their centroids, their midpoints. So the center of the x component is -3 and y component is 1.5. Why -3? Because we can see here that the radius is 3 and it is located in the negative x-axis. This is the x-axis. And then finding the centroids of our line 2. So we have a formula here. Our x is 0 and our y is, so we can just solve this here, y component. The formula is 2r over pi. There you go. So if we put the radius here, 2 times 3 is 6. So the answer will be 6 over pi. So we'll put here 6 over pi. It's in this also. Semicircle. X is 0 and y is this formula, 2r over pi. So next here, 3 inches. How can we get this? We will redraw this. So of course, we will get the midpoint of 3. So we will just divide it into 2. That is 1.5. And I'll call this A and B. This is 20 degrees. So how can we find the x and y component? So we have our previous lessons, SOHCAHTOA. For sine is opposite over hypotenuse, and for cosine we have adjacent over hypotenuse. If we simplify this, if we get the b, this is equals to 1.5 sine and the degree 20. Again, if we simplify this, is 1.5 cosine in the degree. So the B is our y component and the A is our x component. If we plug this in, or if we solve this in our calculator, 1.5 sine 20 is 0.21. Oops, sorry. I'll just fix the camera. Here we go. Again, 0.51. 0.51 in meters. And again, 1.5 cosine 20. 1.41. So we have the x and y component. But first I'll put 3 plus by finding the x component, because the radius here is 3. So I will add 3 plus the a, 1.41. 1.41. And the y component is just 0.51. Okay, so after plotting this, you've plotted all correct, then you are halfway done. So let's do the solving. X component, the length, and the x component is 3 plus the length of line 2. Oops, sorry again. Okay, back. 3 pi times the x component is 0, so we can see that this is 0. It will be cancelled. And the length of line 3 is 3. X component is 3 plus 1.41 all over the total length plus 3 pi plus 3 plus 3 pi plus 3. If we put that on our calculator, 3 times 3 plus, I will not write the 3 pi because it's 0. 3 times 3 plus 1.41 all over 3 plus 3 pi plus 3. Okay, so this is the answer. 1.44. 1.44 meters. Don't forget the unit, guys. So let's do the y component. Again, write the length and the y component of the length of each of the length. 3 pi times 6 over pi, it's 3 pi times 6 over pi. That's how I get it. Times again 3 times 0.51 all over, just copy this because that's the total length. If we put that on our calculator, 3 times 1.5 plus 3 pi times 6 over pi, I will not, okay, never mind, plus 3 times 0.51 all over the length. 3 plus 3 pi plus 3. This is the answer. 1.56. 1.56 meters. meters. So this is our x and y components. This is the centroid. There you go. That is the centroid of this problem. Let's go to our problem number 3. Areas in 2 dimension. Locate the centroid of the given shaded area with respect to the given x and y axis. So this is the shaded area, and this is the whole. So we will only find this area only and find the centroid. So I am going to divide this into 3 shapes. So this will be my triangle. This is my area 1. For naming it, this is my area 2, and this is my area 3. So I will put here my area 1. I will put here area 1. My area 1 is, the formula is 1/2 BH for triangle. If we substitute it, let's find the base. 4 plus 8, 12. That's our base. And the height is, how can we find the height? If this is 6, from here to here, and this is 5. So I will just add this to 6 plus 4 equals 10 plus 5. 6 plus 4. Okay, 6 plus 4 is 10 minus 5. So 10 minus 5 is 5. Oh, I forget the 1/2. Okay, so if we put that on our calculator, 1/2, 12 times 5, it's 30. 30 inches squared. Our area 2, the area 2 is, the base is 12. This is the formula, by the way. So the base is 12 and the height is 5. So 12 times 5, I believe that is 6. 12 times 8, I believe that is 60 inch squared. Don't forget the square because it's an area. Let's move to area 3. So I will put here pi r squared because that's the formula of the area of a circle. But I'll put negative. So as we go back to the note, this is the note. Treat holes, empty spaces in composite components as negative weight or area. So that proves it that this will be negative because this is a hole or a empty area. So we will remove it, so we will put negative. That's the reason. And negative pi r squared, if we substitute, we can see that this is 3 inches. So the 3 squared is 9. So this will be negative 9 pi. Okay. Now we have the areas. We'll have to find the centroids of the area. So for area 1, what are the centroids? For triangle, the formula is base over 3. B over 3. That's in our formula. So our base is 12. 12 divided by 3 is 4. And for our y, we can see that it goes up. So we have 5. So we'll put here 5. 5 plus. This is also 5 because 6 plus 4 is 10. 10 minus 5 is 5. So we'll put 5 over 3 because that's the formula, h over 3. So the answer is 6.67. 6.67. So for area 2, so the base will just multiply. Find the centroids. You will just add 8 plus 4 is 12 divided by 2. That is 6. So the y-axis is 5 divided by 2, 2.5. So for area 3, the area 3, we can see that this is the centroid and it is given 4 and 4. So again, after plotting, you are halfway done. Let's go on to the solving. Here, x component, write the areas, multiply with the x component. So 30 times 4 plus 60 times 6 plus, by the way, this is a negative, so I'll put bracket here, negative 9 pi times 4, close bracket, all over the total length. So we will just add this 30 plus 60 minus, don't forget the minus, 9 pi equals to, so if we put that on our calculator, 30 times 4 plus 60 times 6 minus 9 pi times 4 all over 30 plus 60 minus 9 pi. So this will be our answer, 5.94. What is the unit, guys? The unit will be inch only, inches. Let's go for the y component. So again, the length, the area, area multiplied with the y component. 30 times 6.67 plus 60 times 2.5 minus 9 pi times 4 all over the length of the areas, the total of the areas, total of the areas. So if we put this on our calculator, we'll have, let me put it first, 6.67 plus 60 times 3.5 minus 9 pi times 4 all over 30 plus 60 minus 9 pi. Okay, 4.81. 4.81 in meters. So guys, just to remind you, we put negative 9 pi to remove this area, so we can have this area only to find the centroid. So the centroid is 5.94 and 4.81. So if we plot it, the 5 is, assume it right here, and the 4.81, it's about to go 5, so it's right here, so it's here. Oops, there is the centroids. Okay guys, that's it. Question number 4. Areas in 2 dimension. Locate the centroid of the given shaded area with respect to the given x and y axis. So I'll name this my A1, A2, and A3. So 1, 2, 3. So we have here 120 millimeters, 45 millimeters, 90 millimeters. So we'll put the area 1 first. The formula here is, for areas, the formula of semicircle is pi r squared over 2. Let me see. Semicircle, pi r squared over 2. Okay, I'm correct. Pi r squared over 2. Okay, and then let's substitute. The radius is given 45, so we'll put pi 45 squared over 2, 3180.86. 3180.86. Wait a second guys, I'll just see. Okay, correct. Area 2. This is my area 2, and the formula is 1/2 base height. If we substitute, we put it on the calculator. The base is 120. Put the 1/2 first. 1/2. The base is 120, and the height is, this is 90. So if we divide it into 2, we get 45. So the height is 45. 2,700. 2,700. Oh, I forget. Don't forget to put millimeter squared, because we are in terms of area. Don't forget it guys. Area 3 is just the same. Because it is just symmetrical. So we'll find the C. The centroids of area 1. So X is here. The X is here. So it's negative. The formula is 4r over 3 pi. That's the formula for our x component in area 1. The radius is, again, the radius is 45 over 3 pi. 19 point, this is just 19.1, negative 19.1. Then the y is 0. That's our C1. For the C2, centroid of area 2, we can see that the x is base over 3. So the base is 120. 120 over 3 is 40. That's the formula, guys. Okay? And the height is 45. So 45 times 2 over 3, 30. So guys, why 2 over 3? Because we can see, guys, that the triangle is far away from the origin. If I'll show you here, if the origin is here, the formula will be 1 over 3 times h. But if the origin is here and the triangle is like this, the formula will be 2 over 3 h. That's what happened here. Why 2 over 3? Because the center is here and we have to go there. So 1, 2, 2, then over 3. It's divided into 3, so 2 over 3. So let's move on to C3. B over 3, our base is 120, so it's just the same, 40. And again, h over 3, 45 over 3 is just 30. But we can see that it is in the negative y value, so negative y axis, so we put negative 30 here. There you go. And you're halfway done to this problem. So let's find the x value. X component 3180.36 times the x component, that is negative 19.1, plus area 2, 2700 times 40, and plus again 2700 times 40 all over the total area 3180.36, plus we can just put 2 times 2700, okay, because it's just the same, you will just add. So if we put this on our calculator, let me put it first. 3180.36 times negative 19.1 plus 2700. So I will just put 2 times 2700 times 40 all over 3180.36 plus 2 times 2700. Okay, the answer will be 18.09. 18.09. What's the unit? Millimeters. Why? Because this is squared times, this is millimeter squared times millimeters, that's cube, and this is millimeter squared. So cube over squared is just millimeter. Millimeter squared, millimeters cube over millimeter squared is equals to millimeters. So let's go to the y component. So I guess I won't be writing this because the answer will be 0. Because if we times this to this and we times this to this and it will be add, the answer will be just 0. And of course 3 times 0 is just 0. So 0 over the area is just 0. So C is equals to 18.09 and 0. That's the centroid. So if we are going to plot this here, it's 18, it's about here. The centroid is here. The centroid is there. Okay? That's it. Okay, next. Our problem number 5. Lines in 3 dimensions. Locate the centroid X, Y, Z of the wire bent in the shape shown. So this is a 3 dimension in lines. So I will name this my line 1, this my line 2, and this my line 3. There, I will just put it here. Line 1, line 2, line 3. So my line 1 is 200 millimeter, line 2 is 500 millimeter, line 3 is 300 millimeter. So the centroid of line 1 is 200. What's the halfway of 200? Oh wait, you can see this is the x axis, this is the y axis, z. So it's like x, y, z. So my x, what is the midpoint of 200? 100 millimeters. Y is 0 because it didn't go to the positive or negative y axis, and it doesn't go to the positive and negative z axis, so it's just 0. Our C2 is, first we have to move here because this is the center, this is the midpoint, the centroid of line 2. So we have to put the x 200, so we can go here, and y axis, what is the midpoint of 500? Halfway of 500, that's 250. And z, of course, it doesn't go to the positive or negative z axis. Centroids in line 3. So of course we have to go all over the 200 and all over the 500. So we can see that it is opposite the positive z axis, so this will be negative. So what is the halfway of 300? It's 150. Okay, again we are halfway done in solving this problem because we already plotted the lines and the centroid. So let's compute for the x component. 200 times x 100 plus the line 2 500 times the x value 200, the x component I mean, plus 300 times 200 all over. Guys, we can just write 100 plus 200 plus 200 is just 500, so we can write that way. So if we put that on our calculator, let me put it first. So 200 plus 200 plus 500 times 200 plus 300. I will not show you anymore because to make it fast, over 500. So the answer is this, 360. What unit? 360 millimeters. Okay. Y component, oops, my camera is falling. Y component is equals to, again, the areas times the y component, 0. Of course, that will be 0 because 200 times 0 is 0. This will be cancelled. 500 times 250 plus 300 . Oh wait, I'm wrong guys. I'll just have to change some things. Guys, this is not 500. I'm sorry, I stand corrected because this is 200 plus 500 plus 300. So that is just 1000. So let's just recalculate. So the answer is 180. Sorry guys, my bad. So this is 180 millimeters all over 1000 equals. So we'll put this on our calculator. Let me put it first. So the answer is 275 millimeters. So for the Z, we can see that the line 1 is already 0, line 2 is 0, so I'll just write this. 300 times negative 150 all over 1000. It is equals to, let me put it on the calculator, over 1000. So the answer is negative 45. Okay, that's it. This is our centroid. C is equals to 180, 275 and negative 45. There you go. So if you plug it in here, the 180 is just here, and the 200 is about here, and negative 45 is about here. So the centroid go here, then here. The centroid is here. That's it guys. Guys, don't forget the units, okay? So next, our problem number 6. Lines in 3 dimension. Locate the centroid of the given deformed wire with respect to the origin of the given space axis. So this is a 3-dimensional again. So first, again, I will name this my line 1, line 2, and line 3. I'll put it here. So first, we don't have line 1 and line 2, but we have given here 200. So this is 200, and the radius is 200 also. So this is 200. So if we will write here, 200, 200. So it's like we're going to use the Pythagorean theorem. So 200, the square root of 200 squared plus 200 squared is 282.84. So our line 1 and line 2 is just the same. 282.84. That's what will you do if you have no line 1 and line 2 but you have this given. Okay? 282.84. For the line 3, we don't have line 3 also, but we have our own formulas. It's right here. I will just show you. There you go. This is a quarter circle. Quarter circular arc, and the length is pi r over 2. So we will use this one. Pi r over 2. Pi r over 2. If we substitute the r, the 200 to r, so this will be 200 pi over 2, and that will be 100 pi. You get it, guys? I'll show you. Because pi 200 over 2, see, 100 pi. Okay, so after, oh, I forget, this is millimeters, because it is line. It is a line. Centroids of line 1. The center is, again, this is a three-dimensional x, y, z. Okay, so the x is here. What's the midpoint of 200? That's 100. What's the midpoint of, again, 200? That's 100. Oh, wait. Sorry. Okay, guys, I'll just explain. The x, wait. The x is here, and the y is here. The midpoint of 200 is 100 in x component. In y component, the midpoint of 200 is 100, so it's just 100. The z is 0 because it doesn't move to the positive or negative z axis, so it's just 0. Then see, the z is equals to the, oh my god, I'm sorry, I have a wrong explanation. In this C1, this is 100, the x, and the y is just 0. Sorry, guys, this is just 0 because y is 0, because we are only having this line. It doesn't move to the y or negative y axis. So z is also 100, guys. Why 100? Because this is 200 and the midpoint of 200 is 100, so that's 100. I stand corrected, guys. I'm sorry. So line 2, this we will find the centroid of this one. So the x is 0 because it doesn't move to the positive or negative x-axis. It's just 100 because the midpoint of the y is 200 and the z is this. The halfway of 200 is 100. Okay, guys, let's just make this 200. It doesn't change at all because I computed for these problems that this is 200. So I'll make this 200, 200 and 200. This stays the same and I change this into 200. Okay? It doesn't change. So line 3, the formula of the line 3 is 2r over pi. That's the formula for the x and y. So the radius is 200. If you plug in 2 times 200 pi, so this will be 400 over pi. X and y are just the same because they are the same radius. So 400 over pi for the x component, and for the y component it's just the same, and for the z it's just 0 because it doesn't move to the positive z-axis and negative z-axis. Okay, so we are halfway done. Again, we'll solve for the x component first. 282.84 times this value, this x component, plus I won't be writing this because we can see that this is 0, it's just 0. So I'll move to the line 3. 100 pi times 400 over pi all over 282.84. I will times this into 2 because this is 2 and this is 2, plus 100 pi. This is 282.84. They are the same. That's why I times it into 2. Okay, 100 pi. So if you put this on our calculator, 282.84 times 100 plus 100 pi times 400 over pi over 2 times 282.84 plus 100 pi. This is the answer, guys. 77.61. What's the unit? In millimeters. For the y component, I will not write this because this is just 0. It will be cancelled, so I will move here. 282.84 times 100 plus, oops, I'm so sorry, plus 100 pi times 400 over pi all over the total length, 282.84 plus 100 pi. So if you put that on our calculator, then over 2 times 282.84 plus 100 pi, and this is the answer, 77.61. So we can see that it is just the same. That makes sense because they are the same here. They're just the same. So let's go to the z component. So I won't write this line 3 because the z component here is 0. If you multiply it to 0, the answer will be just 0. So this one, I'll put 2 times 282.84 because they are the same value in the same z component. There you go. Over the length, the total length. So if you put this on our calculator, this will be 2 times 282.84 times 100 over 2 times 282.84 plus 100 pi. So this is the answer, 64.29 millimeters. So that's it. That's our answer. 77.61 and 64.29. Is that 29? Oh, it's 29. So if we plug it here, the 77 is right here, and the y77 is right here, and the 64 is about here. So you can imagine that this is the centroid of this figure. This is our answers. Next, our problem number 7. Area in 3 dimensions. Locate the centroid of the given plate with respect to the origin of the given space axis. So this is an area at 3-dimensional. So we have here 30 inches, 18 inches, and 20 inches. So let's name this my A1, A2. This is my area 2, area 3. I'll put it here. My area 1, my area 2, and my area 3. Okay. So my area 1, the formula is base times height. So 30 times 20, if we put that on our calculator, it's 600 inch squared. Don't forget the squared, we are in area. So area 2, the formula of area 2 is pi r squared over 2. Pi r squared over 2. Our radius is, you can see that this is the diameter 20. So the radius will be 10. 10 squared over 2. So if you put that on our calculator, ten squared over 2, the answer is 50 pi. Okay, I'll write here 50 pi inch squared. Don't forget it, guys. So for area 3, 1/2 base times height, 1/2 BH. So if we substitute the base and the height, the base is 30 and the height is 18. So if we plug it in our calculator, 30 times 18 There you go, 1/2 times 30 times 18, 270 inch squared. Don't forget the unit, guys, it's very important. So we have C1, C2, and C3. So for C1, the centroids, this is the X. So for area 1, it didn't go to the positive or negative x-axis, so it's just 0. And for Y, it goes to the negative y-axis, and the half of 30 is 15, so negative 15. And for Z, it's in the positive z-axis, the half of 20 is 10. Okay, so here we have a formula here, 4r over 3 pi. 4r over 3 pi. So the radius again is 10. 4 times 10 is 40. 40 divided by 30. If we can see, 40 divided by 4, it's just 40 over 3. So let's just put 40 over 3 pi. Okay, 40 over 3 pi for the, oh wait, 40 over 3 pi is for the, let me change this, let's move it here, the C2, sorry guys, wrong again. So the X is 0 because it didn't go to the positive x-axis or z-axis, that's why it's 0. Okay, the Y is 40 over 3 pi because the formula 4r over 3 pi is substitute to this radius. 4 times 10 is 40. 40 over 3 pi. So the Z is just the half. The Z is just the half of this 20. It's just 10. You know why it's 10, guys? Because this is the origin and this is 20. So the half of 20 is 10. So we have to go here because that's the centroid. We're finding the centroids. So again, for area 3, are you following, guys? Wish you could follow. So centroids for area 3, the X here. So the origin is here. The triangle is in the origin. So 18 over 3, you can put that. 18 over 3 is 6. That's the X. And the Y is negative for sure because it's in the negative y-axis. 30 over 3, that's 10. And the z-axis is just 0 because it didn't go to the positive z or negative z-axis. Okay guys, again, after plotting this, we are halfway done to our problem. So let's go to our x component. Let's write the areas. 600 times 0, the x component, this will be just 0. Again, this is just 0. 50 pi times 0. These two will be cancelled because anyone that is multiplied with 0 is 0. 270 times 6 all over the areas, the total of areas, 50 pi plus 270. So let's put this in our calculator. 270 times 6 over 600 plus 550 pi plus 270. So here it is, 1.50 1.58 inch only is our x component. Let's go for our y component. Again, this is 600 times negative 15 plus 50 pi times 40 over 3 pi, 40 over 3 pi plus 270 times negative 10. 600 plus 50 pi plus 270. Let's put this in our calculator to find the answer. So 600 times negative 15 plus 50 pi times 40 over 3 pi plus 270 times negative 10 all over 600 plus 50 pi plus 270. So the answer is this, negative 10.74. Negative 10.74 inch. Don't forget the unit. Always remember the unit. So again here, 600 times 10 plus 50 pi times 10. I won't be writing this because 270 times 0 is just 0, so leave it there because it only will be cancelled. 600 plus 50 pi plus 270 equals, let's put this in our calculator again, times 10 plus 50 pi times 10 over 600 plus 50 pi plus 270. There you go. The answer is 7.37 inch. There you go. So that is it. This is our centroids for this problem. Let's write 1.58, 10.70, negative 10.74, 7.37. There you go. So if you will plug it, 1 is about here for x and for y, negative 10.74 is right here. So for z, 7.31, it's about here. So the centroid, you can see, if you can imagine, the centroid is about here. There you go, the centroid is there. Okay guys, move to our problem number 8. Areas in 3 dimensions. Locate the centroid of the given plate with respect to the origin of the given space axis. So I will name this my A1, A2, A3, and A4. So we can see that the millimeters are 100, 100, 100, 100, 100, 100, and the radius is both 50 millimeters. So I'll write here my A1 is just the same as my A2 because they are just the same. So this is base times height. The base is 100 plus 100, 200. That's the base. And the height is 100 plus 100. Again, 200. And the answer will be, if we put that on our calculator, it's 40,000. 40,000 millimeter squared, guys. Don't forget the squared. And our A3 is just the same as A4 because same radius and same shape. So we have a formula here. Pi r squared. That is our formula. And we will put negative because we will remove this area and this area. We will only include this area, the rectangle. So negative pi r squared, that is negative pi. The radius, it says 50 millimeters, so we will put 50 squared equals, so we need to put that on our calculator. 60 pi 60 squared, 3,600. Negative, guys, don't forget negative. Pi millimeter squared. Okay, so let's find the centroids. The centroid of area 1 is, it's just in the origin. The x component is 0 because it doesn't move to the x or negative x axis. The y value is 0 because it's just here, the center is here. And the z is 100 because it is given 100. Our C2, area 2, here our x is negative 1, positive 100 because it goes to the positive x-axis. If your plate is right here, then it's negative, but the x is here, so it's positive x. Y is 0 because it don't move to the positive or negative y-axis, it's just here, so 0. And the z is also 0 because it didn't go to the positive or negative z-axis. Centroids in area 3, our x is again 0, our y is again 0, z is 100. And our centroids in area 4, our x is 100, the y is just 0, it stays here, and the z stays here. Okay, so we are halfway done to this problem. Let's compute for the x component. So I won't write the area 1 because this is 0, and if you multiply it to 0, it stays 0. So I'll put the area 2. Area 1 and area 2 is just the same, so I'll put area 2, this is area 2, times the x component 100 plus, I won't write the area 3, but I will write the area 4, but they are just the same, so I'll put 3,600 pi times 100 all over 2 times 40,000 because they are just the same. 2 times negative Okay, this is also negative. I'll put bracket. This is negative because this is negative. Okay, negative 3600 pi. So if we put that on our calculator, 40,000 times 100 plus negative 3600 pi times 100 all over 2 times 40,000 minus plus 2 times negative 3600 pi. So the answer will be 50. So our x component is 50. Let's go find the y component. So the y component is just 0. You can see, guys, all the y component is multiplied with 0. So this will just be 0. Don't forget to put the unit. Put the unit. It's just 0. So in z, you put the area 1 multiplied with 100 z component plus, I won't write the area 2, it's just 0, but it's just the same. I will write the area 3. So it is again negative 3600 pi multiplied with 100. I won't write the area 4 because it's 0. Again, just rewrite the total area. Okay. So if you put this in our calculator, 40,000 times 100 minus 3600 pi times 100 all over 2 times 40,000 plus 2 times negative 3600 pi. Okay, the answer is 50. Okay, guys, so that's it. That's our centroids for this problem. So if we will plug it in here, the x component is, it says 50, so it's about here, and y component is 0. Obviously it didn't move, but this is also 50, it's about here, so it's about here. The centroid is about here. So that's it, guys. We're done for this problem. Our ninth problem: volumes in 3 dimensions. A body consists of a right circular solid cone of height 50 mm and radius 20 mm placed on a solid hemisphere of radius 20 mm of the same material. Find the distance of center of gravity of the body from D. So in this problem, we have volume. This is a cylindrical cone. This is a right circular cone, sorry, and this is a hemisphere. So we have the formula for this cone, and that is this one, to find h over 4. And from here to here, this is we will go back to our formulas. this. Here you go. This is for cylinder. There you go, h over 4. It's right here. From the origin to the midpoint. And this one, hemisphere, from the origin to midpoint, like this one, from the origin to midpoint. The formula is 3r over 8. So let's write here 3r over 8. There you go. So we need to find this one, our y1. We need to find this one. So how can we find this one? If this is 3r over 8 and this is our r, so we have to minus it. R minus this line to find this y1. Okay, so that will be r minus 3r over 8. This is in here, 3r over 8. So if you simplify this, 8 times r is 8r minus 3r. So 3r minus 8r over 8. So if we 3r minus 8r is negative 5r over 8. So negative 5r over 8 is the formula to get this, one. So we will exclude or remove the negative because we are talking about the distance. So it's just 5r over 8, and then let's substitute the r. So 5 times 20 over 8. If you put that on our calculator, that will be 5 times 20 over 8. This is the answer, 12.5 millimeter. So next, this is our y2. There you go. This is our y2. So we find the y1. This is the y1. Now we need to find the y2 because it is looking for the distance. It is finding the distance here. The y. We are finding this one. And we're going to solve it later. So y2, how can we find it? H over 4. So the h is this one, the height of the right circular solid. So we will put 50 over 4 because the height is 50. So we have 12.5. So that is the 12.5, the distance from here to here, 12.5. So how can we get the y2? We just have to add this 20 because that is the radius. 20 plus 12.5. If you put that in our calculator, 20 plus 12.5, it's 32.5. Am I correct? I'm correct. So our y2 is 32.5. That's our y2. So we're done having the y1 and the y2. Oops, sorry. So let's find the volume. The volume of This will be my volume 1. This will be my volume 2. So if you will find the volume 1, the formula will be that this is a hemisphere. The formula of a hemisphere is 2 over 3 pi r cube. So if we substitute this 2 over 3, our radius is 20. If we put this on our calculator, 2 over 3 pi times 20 raised to the third power, then I'll just write this one, 16,000 over 3 pi. 16,000 over 3 pi. So for our volume 2, for the cylinder, the formula is, the formula is 1/3 pi r squared h. That's the formula for the volume of this right circular solid. Then if we substitute 1/3, the radius of this cone, right circular solid, is 20, and the height is 50 millimeters. So the answer is, oh, don't forget, what's the unit of this one? Millimeter what? Cube, because it is in terms of volumes. Cube. So 1/3 times pi times 20 squared times 50. 20,000 over 3 pi. 20,000 over 3 pi millimeters cube. Okay, so the next step is solve it, because we already find the y1 and the y2. So our formula is total volume is equals to y1 v1 plus v2 y2, or v1 y1 plus v2 y2. Can use either way. So we'll get this y bar to find this y bar. The y bar is y1 v1 plus v2 y2 all over total volume. So the distance, the v1 y1, the v1 is this 16,000 over 3 pi times y1 12.5 plus 20,000 over 3 pi times the y2, it's 32.5 all over the total of the volumes. Just add this one, 16,000 over 3 pi plus 20,000 over 3 pi. So let's put this on our calculator to know the distance. 16,000 over 3 pi times 12.5 plus 20,000 over 3 pi times 32.5 over 16,000 over 3 pi plus 20,000 over 3 pi. So the answer is 23.61. Okay, millimeters. So this is our answer, 23.61. Just to clarify guys, this is millimeters. Okay, 23.61 millimeters. This is 23.61 millimeters. Next, our problem number 10. Volumes in 3 dimension. Locate the center of mass XYZ of the homogeneous block assembly. So first, I name this my volume 1, volume 2, and volume 3. So I will put it here, my volume 1. So how to find the volume? We can see here, from here to here is 200, and it is, let's add this 50 because it's the missing piece. So 250 times, let's get the width. The width is 100. It's right here, it's written here, and the height is also 100. It is written here. So if we put that on our calculator, this will be a very big number. So it's, I guess it's 2,500,000. 2,500,000 millimeters cube. Don't forget the unit guys. And volume 2, the length first, this is 100, and we can see here that it is also 100, so the length is 200. By the way guys, the volume of a rectangle is length times width times height, just so you know. Okay, so the width is this one, we can see it's 150, and the height is again 100. And let's solve to find the volume. 200 times 150 times 100. You can see it's 3 million. 3 million millimeters cube. Okay. Wait, I will just analyze. I will just repeat these two to see if I'm correct. 2 million, 3 million. Okay, I'm correct. So volume 3. So the formula is 1/2 base, height, and width. So the base will be 100, the width will be 50 and the height will be 100. It's written here. So if we put that on our calculator, 1/2 times 100 times 50 times 100, it's 250,000 millimeters cube. Okay, so after that we are going to find the centroid. So how can we find the centroid? C1, I will draw the X and Z. So we'll draw the X and Z. This is the easiest way, guys, so you won't be confused. It is written here that this is 100. You guys, this is Z, this is X, this is Z, and X and Z. So just picture it out. This is 100, so I write here 100, and this is 100, the Z, so I will write here 100. So for Z and Y, so this is the picture. Come up with the picture. So it's like that. It is written like 200 plus 50 is 250, and the height is 100. Okay, let's write the centroids of volume 1. So our X, we can see the half of 100 is 50, and Y, the half of 250 divided by 2 is 125, and the Z, half of 100 is 50. So here you go, our C1. To find our C2, we will do the same way. So XZ, we can picture out from X to Z, this rectangular, and 100 plus 100, it's 200, and the height is just the same, 100. So if you will picture the Z and Y, the rectangle is here, right? There's a space here. So this is 150 and this is 100. So if we are going to find the centroids of volume 2, the X is half of 200 is 100, the Y, half of 150, I guess it's 75. Double check. Okay, I'm correct. 75. But there is another box here, right? And that is 250. So 75 plus 250 plus 75 is 325. Don't forget, guys, you need to add this up. That's why we write it this way, so we won't be confused. So 250 plus the half of 150, which is 75, is equals to 325. So the Z, the height is 100 divided by 2 is 50. Okay, for C3, ZX and zy. So we will include this one, the volume 3. So it will be, first let's put this rectangle is this one. It is said that it is 100 right here, and there's a triangle over there. Put it there. In this area, it is said that it is also 100, and the height here is 100. It is said here. So facing zy, it is like a box facing zy. Okay, don't be confused. Facing zy, the length of this is 50, and the height is just the same, 100. So we will find the centroid of volume 3, this one, the volume of this one. For x component, 100 plus the half of 100, so which is 50. So 100 plus 50 is 150. And for the y, the half of 50 is 25, and of course z is always 100. The half of 100 is 50. That's it. Now we are halfway done in solving this problem. So I'll be needing another paper. I'll put it here. There you go. So having the x component first equals to the length, which is 2,500,000 times 50, the x component, plus 3 million times 100 plus 250,000 times 150 over the total volume, 2,500,000 plus 3 million plus 250,000. So if we put this on our calculator, the answer will be 2,500,000 times 50 plus 3 million times 100 plus 250,000 times 150 over 2,500,000 plus 3 million plus 250,000. Okay, the answer is 80.43. 80.43 millimeters. Because why millimeters? Because this is cube and this is millimeter cube and this is millimeter. So millimeter cube times millimeter is equals to millimeter raised to 4, and this is millimeter cube. So millimeters raised to 4 over millimeter cube is just millimeters. Guys, be careful of your units. It's very important. So again, 2 million times 125 125 125 plus 3 million times the y component 325 plus 250,000 times the y component all over. I'll just copy this one here. It's just the same, okay? So if we put that on our calculator, 2,500,000 times 125, guys, that's 125, plus 3 million times 325 plus 250,000 times 25 all over the total volume 2,500,000 plus 3 million plus 250,000. Guys, it's 225 millimeters for our z component. So we're having 2,500,000 times the z component 50. We can see that it is all 50, the z component. 3 million times 50 plus 250,000 times 50 all over, again the same, it's just the same here and here, okay? Don't be confused. So we will write in our calculator 2,500,000 times 50 plus 3 million times 50 plus 250,000 times 50 all over, again the total volume 2,500,000 plus 3 million plus 250,000. The answer is 50. Okay, that's it. We're done. So our centroid C, our x is 80.43, 225 and 50. That's our centroid. So that's it. If you will plug it in here, the x is 80.43, it's somewhere here over 50, and the y is 225, it's right here, I guess. 225 right here, and the z is 50. Of course, it's in the middle. So the centroid is in here. It's in here, in the middle. That's it, guys. This is the answer. This is the answer in our problem number 10. Okay, so that's it, guys. I hope you learned something.